Okay. So I'm going to start with homework last time. It seems that many of you have some difficulties, have some challenges. Um, so it's pure geometry questions. The first one, I think most of you have found the right answer, but only for some of you just understanding, okay, what is the segment? The segment is actually a straight line with two ending points, right? For instance, here the AI, of course, is a segment, but the AB is also a segment because AB has two ending points and this straight line. So it's asking in the segment AI, there are also some sub-segments, some sub-segment that's AB, AC, like CE or EG, for instance. So the purpose of this question is asking how many segments. Of course, it's not necessary with the same length. Not necessary with the same length. Length can be 1, can be 2, can be up to 8. Yeah. Okay. Um, the second question is a hexagon. Of course, I saw some interesting solutions from you. You're saying, okay, some of your solutions try to use projection of the segment to horizontal or to vertical lines. That's very good. That's very good. So basically, the hexagon is not a regular hexagon. If you have a regular hexagon, you can say AB is the same as DE. But in this case, AB is not the same as DE because they are not regular. They're not regular. The same as EF and BC, we cannot say, we know already EF is 1, BC is 2, right? So the easiest way to work on this question is we extend the three lines like A, F, B, C, and D, E to the both ends because each internal angle is 120. So here you have 120, you have 120. So in other case, in other words, is that the exterior angles here, here are all 60 degrees. So you have the 60 degrees, you have a both, or you have 360 degrees, meaning that the extension parts are indeed a regular triangle. So then we can say, okay, what is the length of, for instance, PQ is easy because PA is 3, FQ is 1, so PQ is 3 plus 5 plus 1. So basically, the length of this regular triangle is 9. It's 9. So by this, we know also the CD. What is the CD length? The CD plus 2 plus 3 is 9. So we can immediately find what A is. Or we can hear is A plus B. This is A plus B plus 1 is 8. It's 9, sorry. It's 9 because it's 1. It's 9. So using these equations, using these relations, it's easy to find out the parameters of the hexagon. A, B, C, D, and E, F. Yeah. Okay. Number 3. So number 3, you can say, I can cut the blue shaded region at two parts. One is like CD, the part over CD, and the triangle as ADC. Yeah, that's correct. That's correct. But more straightforward is say, if the ADC, ACD, or here, we can convert this as the OCD. Why? Because they share the same base. They have the same base as a CD. And if we draw a line, draw an altitude over CD, if we draw an altitude, a height over CD, so that is the same height or the equal height. The equal height, the same base. So meaning that the area of ACD is the same area as OCD. So we can convert the area of the blue shaded region as a sector OCD. Yeah? So actually it's the sector of the OCD, the same triangle, the same, let's say, same region above CD and the equal area of the OCD. And then it's, you know, immediately this angle is 60 degrees, so it's 1/6 of a whole circle. Yeah. Okay, number 4. Many of you found the right answer. So actually here, what I use is I divide this square into 4 congruent right triangles, and I divide the bigger square ABCD also into these small triangles, and then the rest of part of work is easier. I just count how many small right triangles there, right? For the bigger one, I count like 20. For the smaller KJIL, it's kind of 4. So 4 over 20 is 1/4, no, 1/5. Actually, it's 1/5 of the area of ABCD. And then it's easy to find what is the area of this. Last one. So we wanted to find the area of ABCD where we know one of the side lengths is 16. Of course, the only task is to find what is the height, and what is the height or what the length of the other, the CD or BA. That's the same, right? So basically, you have to know some properties of a semicircle. If you have a semicircle, like F and E, which is a diameter of this circle. And if you draw a line, for instance, CF, so a point on the semicircle, and CE, so the line contacting the both end of the diameter, for instance, as you see here, or here you can do the same. And then you find, actually, this is the radius. Yeah, the CO is radius. Or you can say the CF and CE, which is perpendicular to each other. So I use the CO is the radius, and we find the triangle here. Actually, it's a triangle here, which DO is half of 16, and this is the radius. What is the radius? Because the diameter is 2 times 9, sorry, plus 16. So we can find let's say the radius is 17, for instance. The radius is 17, and now we know the DO is 17 minus 9, which gives 8. So 8 and 17, and again, we get the CD is 15. So that's the solution 1. Another solution is that we connect CF and CE, where you get a right angle here. You get a right angle because it's a property of a semicircle. Yeah, and then you find what the CD is. That's we know it's already. Yeah. Okay, so that's a short summary of the homework last time. Let's switch to the new content. Okay. Okay, so the new content, we have one lecture focusing on the competitions. Yeah. I don't know whether everybody has already participated in the competitions. I know something about from Sibo. He attended like a STEM Olympiad. Maybe some of you have tried this out. I don't know, Annie or Wenyue, or Alston from UK. I don't know exactly, but then we still spend one lecture time on the competitions. So basically, in Belgium, if we're talking about students from the first year of middle school to the third year or the fourth year of the middle school, there are multiple mathematical competitions available. And first of all, you know the kangaroo competitions. So it's mainly for the Dutch-speaking area, where the students from the year 1 to year 2 allowed to participate. Yeah, the Wallaby edition, and same from for the students in the first year and second year. The students in the French-speaking area can also participate the OMB mini level. Also for the students living in Brussels, I think As still, you're also able to participate and OMB as well from the French-speaking part. And for the Dutch-speaking part, for year 3 to 4, there is a JWO, the Junior Wiskunde Olympiad will be available. But of course, if you're in the year 3 and 4, in the French-speaking area, you also have the OMB, not mini, but the MIDI edition. So basically, you see they're all multiple choices questions. They are slightly different from one to another. Regarding to the time, for instance, regarding to the number of questions, but basically there are 24 to 30 multiple choices questions. For OMB, they will have also a few, let's say, questions with integer numbers, from 0 to 999. And each question is valued of 5 points, but if you did not give an answer, you are able to have 1 or 2 points. Of course, then it's asking, many students ask, when I should give an answer. For instance, I would say if you're quite confident, okay, I can try. Of course, I'm not so sure the answer will be A, for instance. But I have 90% of the confidence that should be A. Of course, you should answer A. But in another case, because there are 5 multiple choices, right? So if you have only 20%, then I don't think that's a good idea. So if you only have a 20%, so that's no difference from one of the options. You will say, oh, I leave it blank. And then you get 1 point, or sometimes in OMB you get 2 points. Why not? So you can leave it blank. Regarding to the difficult scales, I would say Wallaby, of course, is the one of the easiest one from the 3 competitions, and the JVO is a little bit harder. But if you thinking about time pressure, I mean that how much time you have. For instance, Wallaby you have 75 minutes, but with JVO you have 3 hours for the first round and 2 hours for the second round. So it's much more time you can have. But OMB gives you only 90 minutes, so just half of the time comparing to the JVO for the first round. They call it elimination round. And also for the semifinals, they call the second round, very equivalent to the second round, but you have much less time. So talking about temperature, I would say the OMB is harder, but the difficulties in JBO is harder a little bit, yeah. Okay, so in the following 45 minutes, I'm going to show some examples. Show some examples of these questions, so you know, okay, what the questions looks like. Are you interested in these questions? And then are you more confident to take part in these competitions? I don't know. So the aim of this lecture is to inspire you to find your, let's say, interest to take part in these competitions. But after this lecture, you will say, oh no, mathematical competition is not my case. It's not what I'm good at, or it's not what I'm interested in. It's okay. So that's not a must. But it will say, I think these questions are quite interesting. Or say, I think the questions is doable, meaning that, oh, it's just within my ability range. Why not? Why not try it out? And I think then you can still have the chance to take part in the coming JVO or OMB for the next year. I think the deadline for subscription is Monday next week, and the Tuesday next week, Monday next week for JVO, and the Tuesday next week for OMB. So you still have 1 day to think about whether or not to take part in. Okay, first 4 examples come from Kangaroo. So it's quite simpler version for the, let's say, for the year 1, year 2 students. Yeah. So the first question, there are 2022 kangaroos and a few koalas in 7 parks. Of course, the number of these 2 animals are different, right? And the condition said that in each park, the number of kangaroo is equal to the total number of koalas in the other 6 parks. So it's asking how many koalas live in the total 7 parks. So basically here, you have 2 variables, 2 kind of variables, kangaroo and koala, and you have 7 parts. So in combination, you will have like 14 variables. It might be very difficult. You say, okay, 14 variables, and do we have 14 equations? But unfortunately, we don't have 14 equations. We have only 7 equations. Let's say if I let xi be a number of kangaroos in the ice park, and the yi be the number of koalas in the ice park, and according to the conditions for the first park, okay, the kangaroo in the first park is x1 is equal to the sum of the total number of the koalas in the other 6 parts. So that's y2, y3 plus 2, y7, right? And x2 for the second part, the kangaroo in the second part is the sum of all the number of koalas in the other 6 parts. So that's y1, but not for y2, and the y3, y4 till y7. So in total, we'll say we'll have a seven equation, but unfortunately, we have like 14 variables. But how can we proceed? Yeah, how can we proceed? We'll say here, of course, the main takeaway here is you might be able to observe these equations are kind of symmetric. It's kind of symmetric because especially on the right, you see it is listed like a square, but of course a diagonal is missing. A diagonal of the y1, y2 to y7 is missing, but for the rest it's kind of square equations. So by this, I'm just thinking add them up. If add all the 7 equations up, because Sx is the sum of the kangaroo, will be the y1, y2, y3 till y7 each appears 6 times, not 7 times, because yeah, if we're talking about their own park, there's one missing. So it's 6 times appearing. So basically you have the 6 times sy, where this is sum of the koalas. So the number of kangaroo is just 6 times of number of koala. And we know that number of kangaroo is 22. So then the number of koala is 337. So 1/6 of 2022. So you do not need to solve all these variables, but then you need, because it's asking the total number of koalas, so you can make it already. The second solution is the same. Yeah, you just mentioned, okay, from here I add y1. If I add y1 on the right, so you get x1 plus y1. And here I add y2 on the right, so on the left you have x2 plus y2. So by this we have x1 plus y1 is the sum of koala. x1, no, so sorry, it should be x2. I make a spelling. It should be x2 plus y2 is also the sum of koala until 7. So then you sum them up again. On the left, you have the sum of kangaroo, sum of koala. On the right, you have 7 times of sum koala. Then you get the same result. Okay? So that's the first example. Second example, for this example, I will say it's not always necessary to find the real solution. Sometimes you can use some tricks to exclude some options, because actually you have 5 options. But if you are able to exclude 4 out of 5, and then of course you can find it immediately what is the left one is the right one, right? the one left is the correct one. So in this question, it's telling, okay, there are in the basket, there are twice as many apples as pears, meaning that the number of apples is double of the number of the pears. And Amir and Sus divide these fruits. And Amir has twice as much fruit as Sus. So those twice apples than the pears. Twice Amir has than the Sus has. And which of the following statements is always true? It's always true, meaning that for any examples, there must be true, for any possible examples. So here we just take one extreme examples. Just think about, okay, if Amir has all the apples and Sus has all the pears, because it's just double, yeah? Apples is twice as pears, and Amir has twice as Sus. So that is a good example. If Amir has all the apples and Sus has all the pears. In this case, the statement A is not correct because Amir has at least one pear. No, in this case, Amir has only apples, no pear, right? And B, no, because there's no pear, so it's not twice as many as pears. C, no, because Amir has like apples, but Sus doesn't have any apples, so C is wrong. D is also wrong. The only E is the possible right answer. E is the only possible right answer. So meaning that if I can exclude A, B, C, D, and of course I don't think about other examples, I don't need to solve what is the real of numbers, what is the exact numbers that both guys have, and then I can say E is the right answer because A to D are all false choices. Okay, the third one is also an interesting one because sometimes it's challenging your imaginations. Yeah. So in this question is asking, okay, Noor built a village with the cubes. Yeah, and the figure on the left is top view. It's from top to the bottom, right? And on the right is another view, but it's not exactly it's a front view or left view or back view or right view, yeah. And it's asking how many cubes could Noor have at most. So meaning that, yeah, how many cubes at most Noor can build on this, but had the same like top view and the same view from another side. So who have think about that before? Who have think about this question? Of course, I shared already with the solutions, but the thing here is that, of course, I don't know what view it is. Yeah, is it a front view? Is it a back view? I don't know. But then I can just list all the possibilities. So the left view is certain, is the top view from top to bottom. And the right one, just imagine if it's a front view. If it's front view, yeah, this is from front to backwards. So then the first column has three towers or three piles, right? And from the front, we know, okay, the highest tower is just 2 cubes. So the highest, meaning the maximum of cubes in this column is 2. So we can use 2 times 3 because this is 3 from the first column. This is 2, so we have 2 times 3. That's the first row. And the second, of course, from the top view, we know, oh, only the front cube has a tower, but all the 3 afterwards there's no tower. But here from the front view we have, oh, the height is full, So it's 4 times 1, 4 times 1. And same as the third and fourth. So basically, we calculate the maximum cubes for each row or for each column. And then we add them up. So if this view is the front view, at maximum, NOR has 21 cubes in total. Yeah, so 21. But the second possibility is that if we see from the left, if this view is see from the left to right, and now this comes to the first row, so which contains only 2 towers, and here the height is 2, so that's why the 2 times 2. And second row or second tower is also 2 towers, so it's a 4 times 2 instead, 4 times 2, and here's a 2 times 1, and we have the same. We sum them up, it gives us 23 instead. And we do the same as back and the right, and for each possibilities, we add them up and find, oh, 24 is the largest number. So meaning that if the view here is a back view, from back to front, and the NOR has like 24 cubes at the most. So 24 is the right answer. Okay. So let's go for the fourth one. A train consists of 18 carriages. And we know the total number of passengers is 700. And in each block of 5 connecting carriages, or each 5 consecutive carriages, or 5 adjacent carriages, there are exactly 199 passengers. And it's asking how many passengers are in the middle 2 carriages. Okay, so we do the same here as because there are 18 carriages, it's not a multiple of 5, right? Because it's talking about a block of 5 connecting. But we can already cut the first 5 and the last 5 out. Yeah, the first 5 will give you like 199 passengers, and the last 5 as well. So we're subtracting the 2 blocks, first and the last, out of the 700 people. So 700 minus 2 times 199 gives 302. So in the middle part, like from 6 to the 13th. So in the middle 8 carriages, the number of passengers are 302. Okay, we focus on this part, and then we count the 5 carriages from the left to the right, or from right to the left. I would say, oh, the number 9 and 10 are counted twice. Right? The people in the 9 and the 10th carriages has been counted twice. Okay, if we counted twice, what will be the numbers? That would be 2 times 199, right? Because each 5 contains 199, but actually we have only 302 passengers. So that's why we are subtracting 302 out of 2 times 199, we get 96 passengers. So 96 is the number of passengers who has been counted twice. So that is exactly the number of passengers who are sitting in the middle 2 carriages. So the answer is D. Well, the people sitting in these 2 carriages is indeed 96. Yeah. Okay, so there are a few examples from Kangaroo. Yeah. So what you are feeling is challenging. You type in the chat. Please type in the chat. You will say, oh, it's difficult, or medium, or easy. Type in the chat your feelings. Okay, everyone, you can type in the chat. It's easy, hard, difficult. Oh, wow. Okay, so many hard. I got already 2 hard, and others. What do you think? Hard. Okay, Sibo also said hard. Wenyu hard. Okay, everybody thinks it's hard. Okay, so actually, Kangaroo is the easiest one. Should be the easiest one. Let's go ahead. So now we have OMB. OMB. mini level. So mini level meaning that the smallest one is applied for the students in the year 1, year 2, and for the year 3 and year 4, they have a middle part, and you have a one session for the students from year 5 and 6 that called OMB Maxi. Maxi is, of course, the max or most difficult ones. Now we have also 4 examples from the mini or from the level for year 1 and 2. Okay. So if A and B, if A plus B is 5, and A squared plus B squared is 19, what is the A cube plus B cube? So basically, it's a pure identity calculations. We call the identities. Yeah, we know some identities like square of the sum, like a difference of squares. Yeah, here we say what square of sum. If you square of sum, then you get a square of A plus B. You get sum of squares. You get sum of squares plus 2AB, right? Plus 2AB. So from here, we can find what is A times B, what is AB is, because we know the sum, we know the sum of squares, and by this identity, we can calculate what is the product of AB. Yeah? The product of AB is 3. And then think about the cube, the sum of cubes. And we also have a sum of cubes identity here. So if we have like A plus B brackets cube is the cube of A plus cube of B plus 3 times A squared B plus 3 times A B squared. And we can do again, so this is the sum of cube, is what we are looking for. And for the 2 terms in the middle, we can take a 3AB out, and the left part will be A, because there's A left, and here the B left is A times B. So in this case, we'll see, oh, this is something we're looking for, right? This is something we should know already. AB should be also know already, and the A plus B is also know already. So we know here the sum of cube can be calculated. Because we know that A times B is 3, A plus B is 5. So then you can get 80 at the end. So the same trick can be used like to find the sum of the the order 4, like the A to the 4th, B to the 4th. We can do the same. We can use also the identities, or we can say not using these identities because this is the identities. We can also say, okay, A to the 4th plus B to the 4th is what? It's like we just think about A plus B times A to the 3rd and B to the 3rd. Okay, and of course it's not the right one because we have to subtract something. Yeah, we have to, because here you get A to the 4th, here you get B to the 4th, and this term is not counted. What is A, B cube minus, and also here, this term is A cube times B. We have to subtract it. And subtract here is easy because we can have AB as a both factor, and we still have A square plus B square. Yeah. So you hear AB is known. AB is 3. A square plus B square we know is 19, and A plus B we know. A cube plus B cube we know is 80. So we can easily find the sum of A to the 4th and B to the 4th. We can do these things again and again. We can find A to the 5th plus B to the 5th. So we can have A to the 6th plus B to the 6th. Nothing strange. Yeah, nothing strange. We can always use these tricks. Okay. Number 6, I think you should be very familiar. If we have the same or similar questions as for the similar triangles, but that one is come from AMC 8 or AMC 10, but in the OMB you see they have exactly the same figures, but maybe the values are different. So in this question, because the RQCP is a parallelogram, this one is parallelogram. So here the PC is 7, so get RQ is 7 as well. And these two triangles are similar. So the BPP and the ARQ are similar. So then we have the RQ is 7, BP is 5. So we know the squares. The RQ is slightly different. It's 7 over 5. And then, of course, AQ should be also 7 over 5 times RP. So where the RP is 6. RP is a 6. So that's why the AQ is 7 over 5 times 6. Yeah, so gives 8.4. So that is the same as one of our homeworks. If you have time to check, you can also check from the similar triangles. There we have the same, very same, or very similar questions. So this is also from OMB semifinals. Number 7, that is an interesting one to me. A hand spinner. So you see in the figure there are 7 circles with the same radius, r. And it's asking to find the parameter of these shape with bold lines, like hand spinner. So what is the parameter of this shape? So you see that all the curves. That's all the curves. So last lecture we know is how to cut and assemble. Yeah, how to cut this shape into some segment we are really familiarized. We're familiarized with. For instance, here we just zoom in this shape, of course, with a pool resolution. Yeah. But then we cut it using the blue lines, and the blue lines forms a regular hexagon, right? And then we see, oh, because they are symmetric, so we can say there we have a inner angle of a regular hexagon is 120. The x is 120, and also for this one is 120. Yeah, because that's also the inner or interval angle of a regular hexagon. And so by this we know the curve, this curve is the same length as this curve, because the radius is the same, and the angle, both have the 120 as the angle. So the body, the black line, the black curve is the same as the red curve. Yeah, because the radius is the same, angle is the same. So basically we can just move this part to here, and we can move this part to here, and move this part to here. It's just 3 parts. Then we assemble it again and end up 3 circles, like this one, and this one. So the hand spinner, the parameter of the hand spinner is just 3 times of the parameter of a circle. Yeah, 3 times the parameter of the circle. And what the circle is, because the circle is r, radius r is 2 pi r, is the parameter of the one circle. So 6 pi r is the answer. 6 pi r is the answer. Okay. Number 8, something about the 3-dimensional. So you might think, oh, 3-dimensional is very challenging. Imagine we have a cube. The ABC is like a point which divides the edge into 1/2. Yeah, 1/2. And we know the edge of the cube is 12. And what is the area of the triangle ABC? Yeah. So you see the ABC, that's also kind of symmetric. Yeah, it's kind of symmetric because the B is 1 to 2, and A is here is 1 to 2, and C divide this A as 1 to 2. So immediately you can find the ABC is also a regular triangle due to the symmetry, right? Due to symmetry. And the next question is that how long is the sides? How long is the side of ABC, right? So what we can do is like we find the BD is 1/3 of the H, so it gives you 4. And EC is actually 2/3 of the H because here it goes to one portion, here the two portions. So CE is actually 8, yeah, and DE is 12. So basically, this is kind of three-dimensional diagonal. So you see, this is also a right triangle. The BCE is also triangle, right triangle where the right angle is the angle E or angle BEC. So in order to find the BC square, we know already the CE square, we need to know the BE square. And the BE square is on the side face because on the side face, the BDE is also right triangle. So the BE square is the sum of the BD square plus DE square. So we have everything ready, right? DE is 12. So square of 4 plus 12 square gets 160. So that's BE square. And the BC square is BE square plus CE square. C is 8, so we get 64 more, we get 224. So that is the square of BC. And you know the regular triangle ABC, what is the area? It's always like square root of 3 divided by 4 times the length square. So again, we have a 56 times square of root 3. So root 3 times 56. So that's also very interesting, and to know how to apply Pythagorean theorem in the three-dimensional. Yeah, in three-dimensional. Okay, so we are finishing the OMB part. And what do you think? Difficulties, medium, and easier? Again, I would say it's hard again. Type in the chat, what do you think? Comparing the kangaroo and OMB, hard. Harder, okay? Harder than the kangaroo, and also harder, okay. Okay, so harder is the right answer because indeed OMB is harder than the kangaroo. Now let's take the last four examples. EAVO, okay, from EAVO. Which of the following numbers is a divisor or is a factor of 3 to the 16th minus 1? So 16th power 3 minus 1. Of course, it's not so practical if you just calculate what exact number it is, because we have to multiply 16 times and minus 1, and then you have to do let's say a verification by dividing each options from this result. So it's not practical, especially during the competitions. But we know a lot of identities. Yeah, we know a lot of identities. So this time, which identities we can use? Which identity we can use is when you have a minus 1 or when you have a minus sign and the both parts are a square of numbers. 1, of course, is square of 1, right? And 3 to the 16 is also square of 3 to the 8th. Yeah. So actually here you get 3 to the 8th. Oh, sorry, it's not good. 3 to the 8th square minus 1 square, right? So you get what? Identity. This is the difference of squares. This is the difference squares. Like you know already, like a squared minus b squared is what? Is a minus b times a plus b. So that's already a factorization. Because this question is about a divisor or a factor. So you need a factorization, yeah? So we do the same as here. So it can be written like a 3 to the a is minus 1 and 3 to the a is plus 1, all right? That's good application. And what for the further? Because 3 to the 8 is still too large, still too large. And this part we can do nothing because it's already plus. What is the minus? Here's a minus again. A 1 a square of 1 and 3 to the 8th we can write like 3 to the 4th minus 1 and 3 to the 4th plus 1. And of course, don't forget the last one, 3 to the 8th plus 1. Yeah, you do it again, and here 4 is again an even number. So we can just say 3 square minus 1 and 3 square plus 1, and so on. You can do again like downward to the 3 to 1, 3 minus 1 and 3 plus 1. So by this, we can do a full factorization of this number without calculating the exact number. And then, of course, now it's easier. The first one is 2, second one is 4, and this one, of course, you still need like a square of 3 is 9, so we get 10. So here we get 4th time, so we get 82. And why didn't I expand it here? Because we got 82. 82 because it's something about a factor from 36 to 54, for instance, 37 to 53. So we find that here is already 41 because 82 is 2 times 41. So that we found, oh, here in this range, 41 is the right answer. 41 is the right answer, okay? Next one, how many digits does the number 8 and 9 plus 99 plus blah blah 2021 lines start with? Start with meaning that as a starting digit, how many ones are there? So this one should be easier because when you see something like 9999, it's always easy to convert it. Convert it like a power of 10 minus 1, right? Like 9 is 10 minus 1, 99 is 100 minus 1, so 999 is 1000 minus 1. So you can do the same for each of the list 999. And this one is be careful to count the right answers, try to count the numbers, right? It's very easy to make a mistake, a silly mistake here. So the principle is easy. And you can say the last one, you get 2021 nines, and then you can convert as a power of 10. So there's 10 to the 2021 zeros minus how many terms here? We have 2021 terms. So let's say we have the minus 2021 at the end. And for this sum is easy, right? So you get all these ones because there's no carryover. So you have 2021 ones and just 1 0 because it starts with 10. So that's why this is 10, this is 100, this is 1000, right? So you get 2021 ones 0 minus 2021. And you can imagine that's just 4 digits. That's 4 digits. So meaning that this one will be affected by 1, this will be affected by 20, this will be affected by 0, and this will be affected by the 2000. So still you have to remove because it's 1, and then here I have a -2. So that's why this one will be also affected. This one at the 10,000th place will be needed to become a 0 because 1110 is smaller than 2021. So that's why this part, I will just write this part out. So if I have a block here, this is block like 1110 is smaller than 2021. So this one will be also turned to be 0 because we have the minus. Yeah, so that's why in total we have 4 ones less. 4 ones less. So it ended up like 2017 ones. So I think that's A, and many students will select the B because it's just say, oh, here just 3. These just 3 ones, but they missed. Yeah, that's the 1110 is smaller than 2021. So that's why this one will be also impacted. Yeah. Okay. Number 11. Again, some symmetry. And we start with let's say, a regular triangle. And it seems like the LMN is also a regular triangle out of a symmetric because what we learned is LN is perpendicular to AC and MN is perpendicular to BC, and ML is also perpendicular to AB. So 3 right triangles, and the rest is also regular triangles. And it's asking what is the area of LMN? What is the area of LMN? And to find it, we can have 2 solutions. One is that, okay, we know the area of ABC, and we find the area of each triangles here, and then we minus 3 times these such triangles. That's durable, yeah. And another solution is that if LMN, we know LMN is also a regular triangle, ABC is also a regular triangle, so they are similar, right? They're similar. This ABC and LMN are similar, and we can just calculate the ratio of the sides. The ratio of sides, for instance, the side is AB for the bigger regular triangle, and LN is the side of the smaller triangle. If we know this ratio, we just square this ratio, and we got the ratio of the areas, right? Because we know already ABC, the area of ABC is 36. Okay, so let's follow the second solution. So if the AB, because L is also kind of perpendicular, but I don't know what the BL is. What the BL is, what AL is, we don't know. We don't know up front. Yeah. So, but interesting is that BL is AN out of the symmetry. Yeah. The BL is the same as AN because they are symmetry, right? And ABC is a regular triangle. So here we get a 60 degree. Here we have a 90. So basically, if you draw a right triangle like this, so here you get a 60, which is A, and here you have an N. Here we get the L. So the 60. So what is the ratios? What is ratios? We know is if you have a 1 and you have like a 2 and the height is square root of 3. So that should be very familiarized. Should be really familiar with these ratios. So AN, what is AN? AN is 1 portion, and AL will be the hypotenuse will be 2 portion, and this one will be square root of 3 portion, right? Okay, so then we know the AB now. The BL is also 1 portion. So AB is actually with three portions, and ml is like the √3 portions. Yeah. So then we get the NL over AB. The ratio of the side, let's say, is what? NL over 3. AB is 1 over √3. So then the square is actually the ratio of the area, because the side is like 1 over square root of 3. So the ratio of the areas will be 1 over 3 square, square of the 1 over square root of 3. So you get 1 over 3, and you know the ABC, the area ABC is 36. So then the LM has an area of 12. So last one. Okay, so something about probability, counting. We know that already, we learned the counting as well. So imagine a jar contains a number of candies, and only 5 of them has a cherry flavor. So 5 of the candies have the cherry flavor, but we don't know the number of the candies. Yeah. And the cherries, okay, the cherries and cherry, okay. The cherries randomly take 2 candies. She takes 2 candies out of the jar, and the probability that the 2 candies are both cherry flavor is 2 over 9. So we know already the probability. We have to find back what the number of the candies in the jar. Yeah. So this kind of question is not so straightforward to think, oh, now we know the number of the candies, we know the number of the cherries flavored candies, and we calculate the probability, because that's really more straightforward. But in this case, we don't know the number of the candies first, but we can assume the number of candies as X. Yeah. For instance, we let the number of candies as X. So out of the X, there are only 5 candies has cherry flavor. So then we say, okay, how often the cherries can just pick two of the candies out of 5. Yeah, the 5 have a cherry flavor. So the numbers of possibility that the cherries pick 2 out of 5, their both cherries flavor is 10. Choose 2 out of 5 is 10. But without this construction, what is the general chances? Like cherries just choose 2 out of X. Yeah, just randomly take 2 candies out of X. So let's choose 2 out of X. So we get X times X minus 1 divided by 2. And the ratio of these two numbers is the probability. It's the probability that the both taste like a cherry. So we know the 10 over this number is 2 over 9. So we have 2 over 9 as the probability. So then we get a what? We get a equation in terms of X. Yeah. And then we found X times X minus 1 is 90. And this quadratic equation, you know it's a quadratic equation, you can solve it, right? And we get one solution is X is 10, and another solution is X minus 9. Of course, number of candies cannot be negative, right? Cannot be negative. So that's why X is 10 is the right answer. Yeah. Okay, again, type in the chat harder or hardest or medium or easier for the EMAO. Harder again. Hard, okay, really hard, okay, really hard from Estelle. So almost you think it's hard, yeah, almost all of you think it's hard, but I don't know. Yeah, what likely you are going to take part in these kind of competitions, but I will say forget what you want to achieve. meaning that you'll say, oh, I want to go into the finals. Maybe it's too high, let's say, ambition. We say, oh, I just try it out. Why not? Because it's just like €3 as a subscription fee. It's just a cup of coffee. I will try it out. Then it's a good. I mean, it's a good aim or good mood to take part in these competitions. But it's not a must. I would say it's not a must. Okay.